Assalamu alaikum warahmatullahi wabarakatuh. Friends, this is our second video on inverter AC board. Last video we detected that the bridge rectifier is short circuit, so I disconnected the bridge rectifier from the circuit, and I also removed this IPM module from the board. We have to inspect this portion before going to the further repair. We have to remove these IGBTs. We have to remove the diodes. Just pull out here, remove bridge rectifier, IPM, because these are connected on these plastic mounting. Now we have four plastic catches, 1, 2, 3 and 4. And if we want to push it back, might be it will break. So we have a guide pin here in this hole. We have to push it down and press it back. Press it to this side because we have space in this portion. So just only press it and push it. So this component tray is open. Now we can check this portion. It have damage, and we can see a damaged contact. So we have to inspect it carefully, and we have to check the tracks, and then we have to check the continuity with other side because this IGBT was damaged. So we have to repair this track. This bridge rectifier is also damaged. We can check it because now it is outside from the board. Set multimeter to diode mode. So this point of bridge rectifier is positive output pin. So connect black lead to the positive output pin, which is at the cut. So we have bridge rectifier short. It is giving one diode is okay, but one diode is short. Now move this lead at this pin. We have one pair in the bridge rectifier that is short. Now move red lead here. It is giving continuity in both directions. So this diode is short circuit. Now check. So in this bridge rectifier we have 4 diodes. 2 diodes are short circuit and 2 diodes are good. So we have to replace this bridge rectifier and we have to repair this track. Input protection for high frequency, over voltage, differential mode noises, common mode noises, first stage filter, second stage filter, then overcurrent protection from surge currents and bypass system, and then we reached at the bridge rectifier. If you want to watch this video, I will suggest to watch this video before we continue to this session. If you have not watched that video, you can go to the video. We discussed after passing all protections, we reach at bridge rectifier. Bridge rectifier takes AC input and rectifies and gives DC voltage. So bridge rectifier is located here. The inner both terminals are AC input terminals, AC terminals, and this one is output and this one is output. So we have to follow this line for negative and this line for positive voltage, and we will continue on these lines. First of all, see here, we take positive voltage, then we have RV10, sorry. This is MNY15, it is MOV. metal oxide varistor, voltage arrestor, and then we have a capacitor which removes the ripples. Positive line here. Now we have to check the negative line. So negative line, this is output, and from this point we reach here. Here are bypass cylinders and reaching here. So negative line will reach the other end of this MOV. Positive here, negative here. Both capacitor and MOV are connected in parallel in positive and negative line. Then the positive line from this point will come to these inductors, choke, reactor. We have two reactors, 1 and 2. If we see here, this reactor have 4 pins in this side and 4 pins in this side. It have 2 coils, 1 and 2. Either we have inductor on the board, reactor on the board, or outside from the board, so it will be the same. So here it is using 2 chokes, 2 inductors, 2 reactors in series. The first one from this point to this point, and this from second inductor, the same coil is here. 1, 2. We have bridge rectifier, then we have MOV, then we have capacitor, which we discussed. These are here, and after that we have 4 coils. 1, 2, 3, 4. 2 in this series, 2 in this series. In the output terminal of the second coil, we reach here. Here we have IGBT, collector of this IGBT. And from first coil, 1, 2, 3, 4, from this line, this is coming to G1. We have 2 IGBTs, 1, 2. And in the same point here, we have D2 rectifier, D1 rectifier. We have this rectifier and this rectifier. 1, 2. 2 IGBTs, 2 rectifiers. So coil is connected to anode and cathode is connected to capacitor positive terminal. So we have 1, 2, 3 capacitors. These are in parallel, anode, cathode. And in this coil, anode, cathode. So both cathodes are connected on the same point, same potential. First coils are connected to collector of first IGBT, second coils are connected to second IGBT. We have 2 diodes. Both cathodes of both diodes are connected to the same point, and these are connected to 1, 2, 3 capacitors in parallel, 680 microfarad, 450 volts. Then from this same terminal, the output terminal, from this point we have MOV here and 1 ripple remover capacitor here. 1, 2 components, one for over voltage, second for the ripples. So one MOV is connected here, the second connected to the secondly we have a capacitor. So in the output of bridge rectifier, if we have any over voltage or high ripples, over voltage will be terminated from here. If we have high voltage, it will become short and it will damage the bridge rectifier, and next circuit will protect it, as we discussed here. If the input terminal, in our last video as we discussed, if we have over voltage here, high voltage surge, it will become short and it will damage the fuse, it will damage the first input component, and it will protect the next circuit because it will make a short circuit. So if over voltage condition occurs, it will become short and it will damage this bridge rectifier and it will protect the next circuit. Then we have these coils, 1, 2, 3, 4 IGBT, and in the negative side of the negative output terminal of the bridge rectifier, if we see here, we have RS2 shunt resistor. It is 8.2 milliohm, 8.2 milliohm, two shunt resistor in parallel. Current will pass from this shunt and it will reach here to the emitter of this IGBT and to the emitter of this IGBT. So both emitters of both IGBTs are connected at same potential. Two shunt resistors, then it is connected to both emitters, and from the same point, if we come inside, this is connected to capacitor negative terminals, this line. So positive will reach through inductors and diodes, but the negative line will reach through this shunt resistor. We have three other shunt resistors. These are for second subject, but this time we will discuss in negative line these shunt, and current will reach at this point and it will also reach at the capacitors. Then it is negative rail, and if these two components are off, IGBTs are off, rectified positive voltage will reach to the capacitors from both inductors, both diodes. When this IGBT is off, this IGBT is off, and routine flowing current will reach from negative terminal to the capacitor negative terminals. So the system will keep monitoring always the current from this point, because our this line this end of shunt is connected to this line, and it will pass the information of the dropped voltage to the processor. After passing these jumpers from here, from the inside of board, it will reach here. So if any time, let's see the diagram, if any time, for example, our this IGBT becomes short circuit, so it will cause to make positive to this line. It will, if IGBT is short circuit, it is not working, in that case it will cause to flow high current, so voltage will drop on this shunt and this voltage will go to current sense line to the processor. If this IGBT makes problem, at that time this shunt will make sense line high. Any component will try to draw over current. In that case, this shunt will measure the voltage. Or if there is no shunt in any circuit, for example, we discuss the sharp AC board, there is a current transducer, current transformer. If there is a current transformer, in that case it should be here. It becomes in the square or rectangular shape. It will measure the current that is used in AC line. Current transformer is used in AC line, but current shunt resistor will be used in DC line, negative line. If it is using current transformer, in that case it will measure the amount of current and it will transfer this amount of current in form of voltage, and voltage will be rectified, and these rectified voltage, they will translate the amount of current. So this current value will transfer to the processor to determine the amount of current flowing in the system for overcurrent protection. If any time overcurrent will flow, the more voltage will generate, will transform in secondary of this current transformer. So current transformer will transfer this voltage and system will know that there is something short circuit. And in this case, it is used in DC line. So if any component will draw more current, these more voltage will go to the system to determine how much current is flowing over there. So this is our PFC circuit, power factor correction circuit. This one, reactor, IGBT, diode. For example, we get 300 volt from the bridge rectifier. From this point to this point we take 300 volts. But for system operation, for example, I need 350 volts. At that time there is a PFC controller, power factor controller. Either it is IC or either it is using microcontroller or some IC like that. If it is controlled by the microcontroller, it will generate pulses and it will drive these IGBTs. We will just discuss one IGBT. It will give pulse to the gate, to the base of this IGBT. If there is no drive pulse, the voltage will pass and it will cause to run a steady current. When from a coil there is a steady current, there is a DC current, then there is no change in current, then there is no varying magnetic field. So voltage will pass, current will flow, and it will charge the voltage at the same voltage. If we give a pulse to the base, in that case this IGBT will switch and it will cause to make a surge. It will cause to flow the current in this line, so it will cause to generate magnetic field by varying the amount of current, because it will provide a short circuit for a while. How much time it is on. So current will flow. When heavy current will flow, it will cause to induce magnetic field. When this magnetic field will increase, so this magnetic field will store energy in this inductor. Now in the off time, when it will turn off the gate, the current will stop. This expanded magnetic field will collapse. When it will collapse, it will generate reverse EMF. It will generate voltage in the inductor. So that voltage will become opposite in the direction. First this end is positive. Now by the collapsing magnetic field, this end will become negative, this end will become positive. So both voltage will become in series. For example, it will generate 50 volts. The magnetic field will collapse. So this 50 volt source will added in 300 volts. So we will receive 350 volt at this capacitor. And this amount of voltage will come to feedback to the controller. So this controller will maintain the voltage level here. If the voltage will decrease, it will increase its switching. If the voltage will increase, it will decrease. So it will maintain the switching time on vs time off. If the voltage at input line will drop, so it will increase its switching to increase the voltage at this point. So it have to regulate the voltage at this capacitor. Now in this case we are using two IGBTs. When it needs too much regulated voltage, because it needs high current, to maintain the voltage it is using two stages, one IGBT, two IGBT. One will on, the second will off. When this will on, this will off. So it will work vice versa, opposite to each other, so that there will no huge surge in the main DC rail. Then it will maintain the voltage at these capacitors. If we have overcurrent issue, might be we have problem in the IGBTs, IPM, intelligent power modules. Sometimes there is no IGBT and there is no diode. In that case, there is a PFC module that have built-in IGBTs and built-in rectifiers. So it have just only the input voltage and it will drive the reactor and it will give charging voltage at the capacitor to maintain the voltage. Sometime in some boards we have just only one IGBT and one diode. Here we are using two IGBTs, two diodes, two reactors. If we have just only one reactor, the function will remain same. Now if we have overcurrent issue, for example E8, HA8, L5, 60, P1, P4, any code which will translate to overcurrent issue, then we have to monitor this area. Or if it is not using a shunt resistor, if it is using current transducer, current transformer, then we have to go to the current transformer section. And the voltage at this DC rail are monitored from 1 to 3 resistors. 1 to 3 resistors. So these 3 resistors and this resistor network, these voltage are transferred from this point to this point to the processor. So this controller will monitor the DC voltage because it is voltage divider network, and we will receive this voltage information here, and this information will calculate it and it will determine the charging level, and in that case it will drive these relays, bypass relays. Where are that? K1 and K2 to bypass these and PTCs, positive temperature coefficient resistors. So if it gives high or low voltage error, in that case we have to check this section. If it is monitoring the DC line from DC rail, that's good. Sometime we have here resistor network and one optocoupler is connected, and the same information as we discussed current transformer, the same information will transfer, voltage transferred. In the sharp we have this diode 1 2 3 4 5 6 resistors, and then we have optocoupler, and this voltage feedback will transfer to the controller and it will check the input voltage. But here this board is monitoring voltage from this point. So this is our DC rail, and then we will continue to, it is IGBT drive. We will discuss when we will discuss this IPM drives and control section. We will discuss this drive signal in our upcoming video. Now we discuss just only the DC rail, how the DC circuit is working. If this MOV becomes short due to over voltage in this section, the capacitor will not charge and our bridge rectifier might be damaged, and in that case we will take high current protection, overcurrent error. If any component, IGBT, diode, these components will damage, we will take overcurrent issue and we will take under voltage issue, because when these components will become short circuit, these components will draw the current, more current than the rated value, because normally they are open. But if any component will become short circuit, it will draw more current, so it will cause to drop voltage in the DC rail. It will generate overcurrent, under voltage. So friends, I hope so this video is informative for you. If it is informative, give a thumb up, and if you have not subscribed my channel, subscribe it, and if you want to watch my videos in future, press the bell icon button. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.